All right, let's get right into it. Today, we're going to tear apart one of the most fundamental concepts in crypto, but one that almost everyone gets wrong at first. I'm talking about the crypto address, that giant string of letters and numbers you've copied and pasted a million times. Turns out, it's way more interesting than just being a destination for your coins.
So what is it, really? If you've always pictured it as like a digital mailbox or maybe a bank account number for crypto, you're in good company. But that's not quite how it works. To truly understand it, we got to flip our whole perspective on what an address actually does. And here it is. This is the key idea right here. Think of an address not as the box itself, but as a public blueprint for a very special lock. You can hand out this blueprint to anyone. They can use it to build a lock, put something inside for you, and get this, you are the only one in the world who has the key to open it. This lockbox specification idea, that's the foundation for everything else we're about to cover.
So this leads us to the first major mental shift. We've got to stop thinking of an address as a place, a location where your crypto is sitting. It's not. Instead, we need to start seeing it for what it is, a set of very precise instructions.
Okay, so here's the more formal definition. An address is a standardized summary of spending conditions. Now, the most important word in that whole phrase is summary. That's all it is. It's just a convenient shorthand for all the rules that someone has to follow to spend the crypto associated with it.
So just to make it crystal clear, an address is a specification. It is an instruction. It is a template. What it is not, it's not your key. It's not a folder or a bucket holding your funds. And this one might surprise you, the address itself isn't even stored on the blockchain ledger. So what is? Yeah, we're getting there.
All right, if an address is an instruction, then how in the world is that instruction made? Well, it's a really cool process that takes your sensitive information and safely transforms it into this public-facing thing we call an address.
So it all starts with either your public key or a more complicated script. That data gets fed into a one-way cryptographic function called hashing. The best way to think about it is like a digital meat grinder. You put your data in one end, turn the crank, and out comes this unique, compact fingerprint. But here's the trick. It's a one-way street. You can never, ever put that fingerprint back into the grinder and get your original data back. And that is the absolute genius of the whole system. You can share this fingerprint, your address, with the entire world, and you're not exposing any of your secret info. The actual key stays hidden, only to be revealed for a split second at the exact moment you decide to spend. It's security by default.
Okay, so now we know an address is basically a hashed instruction. But that long string of characters isn't just random gibberish. No, it's actually packed with super important information. So let's decode one. When you get right down to it, every crypto address is made of three core pieces. You've got a prefix, a version type, and something called a checksum. And each one does a very specific, very important job.
Let's break this down. First up, the prefix. Think of the BC1 at the start of a Bitcoin address or Kaspa for a Kaspa address. That tells the network, hey, these instructions are for this specific blockchain. Super important because it stops you from accidentally sending your Bitcoin to the Kaspa network. Next is the version type. This little piece tells the system what kind of lock to build. Is it a simple lock for one key, a more complex one for a multi-sig wallet? And finally, the checksum. This part is brilliant. It's basically a built-in typo detector. If you accidentally mistype even one character in that long address, the checksum will fail and the wallet will just say, nope, that's not a valid address. It's a simple feature that has saved people from losing, well, everything.
So you take all that data, the fingerprint, the prefix, the version, the checksum, and the system bundles it all up and encodes it into a format like Bech32. All this really does is make that long string of data easier for us humans to look at, to copy and to share without messing it up.
So we've built the instruction, we've decoded it. Now for the final piece of the puzzle. What actually happens on the blockchain itself when you use an address? This is where it all clicks into place.
And that brings us right back to that bombshell I dropped earlier. If that long string of characters we call an address isn't actually written down on the blockchain, then what is? Here's the big reveal. When you send crypto to an address, the network takes that address and uses it like a blueprint. It translates it back into its original, more complex form, a locking script. That script is what actually gets recorded on the ledger. The address is just the user-friendly summary of it. So here's how it all plays out. The lock is basically the crypto on the ledger that's tied up by the rules of that locking script. Then the unlock happens when the rightful owner comes along and provides the exact data, usually a digital signature from their private key, that perfectly solves the mathematical puzzle laid out in the script. When the network sees the correct solution, boom, the funds are unlocked and can be spent.
So, let's wrap this all up. If you remember one thing, and only one thing, from all of this, let it be this. A crypto address is not a location. It's not a folder where your money lives. It is an instruction. It is a public specification for building a lock that only you can open.
And that kind of leaves us with a really fascinating question to chew on, right? Today, most addresses are just instructions for pretty simple locks, like unlock with this one's signature. But the system is built to handle so much more. So what happens when our addresses become instructions for really complex locks? Locks that might need 3 out of 5 people to sign, or that can only be opened after a certain amount of time has passed. We're just scratching the surface of what's possible here.